Okay, so our last video got cut off, but like I said, you're just moving every one of these points down 2. So if you kind of need to do the math, that's fine. We're going from 1.5, like from 0 down 2, so that's easy, 0 to -2. But from 1.5, I'm sorry, from 1/2 down 2 would give you to -1.5. So there's a little bit of math involved here, so just be careful as you're shifting this down because of the amplitude. So a little strange, but that's how you do it. So 5 and 6 are kind of the same question, but slightly different. So they were just with different trig functions, really. So evaluate tangent sine inverse of √3/9 without plugging into your calculator. All right, so we talked about this. We work from the inside out. So this inside piece tells us our triangle. Now remember, our triangle goes back to SOHCAHTOA. So sine is opposite over hypotenuse. So √3 9. So √3 opposite, 9 hypotenuse. So I need to find that third side. So x squared plus √3 squared is equal to 9 squared. X squared plus 9 is equal to 81. So x squared is equal to 81 minus 9 is going to be 72. Had a little mental lapse there. So, and then square root of that. So x is equal to 72 is the same thing as 9 and 8, or yeah, we can do 9 and 8. So 9 and 8, so we could say 3√8, or this would be 6√2. 72 is the same thing as 36 and 2. So that's how we get 6√2 as a simplified radical for the missing side. Okay, so once you have your triangle set up, we're just going to get the tangent of this angle. So like I said, inside gives you the triangle, and then you use that trig function on the outside. So tangent's going to be opposite over adjacent. So tangent of theta is going to look like √3 over 6√2. Now, when we rationalize denominators with a radical, you only rationalize with the radical. Don't worry about the 6. Leave the 6, no big deal. So √3 times √2 is √6. And then you have 6 on the bottom. √2 times √2, the roots go away. So you really just get √6 over 12. You cannot reduce this. It is what it is. Leave it. It's perfectly fine. My answer here is √6 over 12. All right, similarly with number 5. So cosine inverse, √5 over 5. Cosine is √5. Hypotenuse is 5. We're going to find that missing side. X squared plus √5 squared is equal to 5 squared. X squared plus 5 is equal to 25. Okay, I'm going to do my math a little bit better the second time around. So x squared is equal to 20. X is equal going to be 2√5. When I reduce that, 20 is the same thing as 4 and 5. √2, 5. So that's what this missing piece is. Now secant, remember, is 1 over the cosine. So secant of theta is 1 over the cosine of theta. So if I find cosine and flip it, I'll get secant. So cosine of this angle is √5 over 5. So I'm going to flip √5 over 5 and get 5√5. Or when I rationalize it, I'm going to get 5√5 over 5, or just √5. Oops, meant to circle that. Not very exciting. We didn't really need to find that missing side. It's just good habits, because it just kind of worked out with this one. But good habits to find all 3 sides of that triangle. My answer here is √5.